This video will cover the second part of Chapter 2, Properties of Water and pH. At this point, you guys should have watched the other video, Ingredients of Life, which discusses some of why water is so important to living things. One good example of why water is so important is that many chemical reactions require an aqueous environment for them to work. And water is also important for dissolving materials for transport. For example, there's water coating the surface of your lungs that dissolves the oxygen and CO2 that goes into and out of your lungs. Water is also used for temperature regulation and is a reactant in some reactions. Many organisms are also adapted to life in water. If we look at a human body, we can see that water is a huge component inside of us. 75% of your brain is water. It helps regulate our body temperature. Water makes up 83% of your blood, which is primarily responsible for transporting food, nutrients, salts, and other materials around your body. Water helps to remove waste, particularly in your kidneys and liver. Your bones have water in them, though not much. And the cushions of your joint also require water. We also see that it helps in the respiratory system with carrying oxygen and dissolving those gases so they can enter our body. It helps with converting food to energy in a process called cellular respiration. Water is important for protecting and cushioning our organs, and it also helps with our muscles. There are 4 properties that allow water to support all life. First, water is cohesive and adhesive. This means water is sticky. Water has a high heat capacity. Water has a low density as a solid, and water is a good solvent. Have you ever thought about the question, why do belly flops hurt? This boils down to surface tension. Water molecules are cohesive. They like to stick together. We can see that this is due to those weak hydrogen bonds between 2 water molecules. Remember, we denote those hydrogen bonds with a dotted or dashed line. If we look at this water at a molecular level, it's kind of like a net at the surface of the water. Some pressure must be applied to the surface of the water before those hydrogen bonds will break. This allows some animals, like spiders and insects, to walk on water. Cohesion, water molecules sticking to each other, and adhesion, water's tendency to stick to other substances, is very important for many living organisms. For example, plants rely on cohesion and adhesion to move water molecules from their roots to their leaves. As the water molecules move, they form a chain going up through the plant. So we see this cohesive property with hydrogen bonds between each water molecule. These water molecules will also form bonds between themselves and the surface of the tubes they are traveling through. This prevents those water molecules from flowing backwards. For plants, this is very important because they do not have a pump in their bodies like animals do. Trees don't have a heart to push that water through their bodies, so they rely on things like evaporation to pull those water molecules up and out of their leaves, and we see this chain effect as one water molecule moves, the others follow suit. Another important property of water is that water has a high heat capacity. This means that it requires a large amount of energy, such as sunlight, to change the temperature of the water. If we think about heat and what it actually is, heat is a measure of molecular movement. Temperature is the measure of how intense the heat is. The more molecular movement there is amongst the molecules, the higher the temperature. So, if we look at a body of water, we can see that there is a lot of sunlight required to cause these molecules to move. This again comes back to those hydrogen bonds in between each water molecule. Every water molecule makes 1, 2, or even 3 bonds between its neighbors. Those bonds must be broken before those molecules can move freely. So it requires a lot of heat energy, or sunlight, to warm up a large body of water. In comparison, if we look at something like sand, sand has a very low heat capacity. The same amount of sunlight beating down on the hot sand at a beach will raise that temperature very rapidly. So, have you ever been to the beach and you've run across the sand and it's incredibly hot? You run to the water, splash in, and you're like, feels so good. The water is much cooler than the sand because water has a high heat capacity. So remember, water has a high heat capacity because it takes extra energy to break all those hydrogen bonds between the water molecules. Those hydrogen bonds also like to quickly reform between other neighbors, meaning that it takes even more energy to raise the heat. The third property of water again has to do with hydrogen bonds and with changing states. For most substances that change states, we go from gas, liquid to solid, generally when we cool or compress the substance. Gases are usually the least dense, with molecules moving quickly and being very spread out. Liquids are more dense than gases, and those substances generally take the shape of their container. If we cool the substance further, we often see a solid form. These solids are usually highly ordered, and the particles are usually more densely packed than the liquid. Water, when moving from liquid to solid, does not follow this normal pattern. Frozen water has a hexagon shape to the molecules because of the hydrogen bonds. When liquid water freezes, the molecules are forced into a hexagon shape due to the hydrogen bonds. This actually spaces the molecules out, making ice less dense than liquid water. We can see that in this depiction here, where the solid ice has very big spaces in between the water molecules. Liquid water, on the other hand, has molecules that are more tightly packed. This means that frozen water will actually float to the top. We know this because we look at ice cubes every day in our glass. The fact that ice is less dense than water is also important for living organisms. If we think about a pond environment, water freezes from the top down. This gives those organisms space below the ice to live and survive. If ice was heavier than the water and it froze from the top, that ice would sink, squishing all the living things below it. If the pond froze from the bottom up, those fish and other organisms would be forced to the top with very little to no water, which would cause them to suffocate and die. The last property of water is that it's a good solvent. A solvent is a substance that dissolves another substance. A solute is a substance that is dissolved in the solvent. So, for example, if we were looking at chocolate milk, yes, I have children, so I look at that every day. The solute is the chocolate and the solvent is the milk. So, water is an excellent solvent. It can dissolve many different substances. For example, a crystal of sodium chloride, also known as table salt, easily dissolves in water. This is due to the charges. Remember, sodium chloride has 2 charged ions. Sodium is positive, chloride is negative. Water is also partially charged due to those polar covalent bonds inside of the molecule. The polar covalent bonds create partial positives and partial negatives on the water molecules. The water molecules will surround the ions, breaking them up and dissolving them in the overall solution. Water is able to dissolve many substances as long as they are polar, charged like our salt, or if they have polar or charged regions inside of them. Thinking about why water is so important, being a good solvent is important inside of a body of an organism. Many substances need to be dissolved to be transported. Things like oxygen and CO2 easily dissolve in water. It's also important for our nutrients from food to be dissolved so that we can digest them and break them down. And remember, many chemical reactions, like turning food into energy, also require water to dissolve the substances so that those chemical reactions can occur. Our next topic are acids and bases. Living systems are highly sensitive to acidic and basic conditions. A small change in the pH of a substance can result in death of the organism. When we look at the pH scale, we're measuring the amount of H+ protons in a solution. pH is actually a log scale, so things are going to be inverse. The more hydrogen ions we have in a solution, the lower the pH will be. So acids have more proton ions than bases. They have a lower pH and can often cause burns. Bases, on the other hand, have more hydroxide ions, or OH- ions. They have a higher pH and are caustic. We often use bases as cleaners in our house. When we look at acidic solutions, the H+ ions are very reactive. Acids can donate H+ to other chemicals. For example, stomach acid is HCl, or hydrochloric acid. Bases have low H+ concentrations or high OH- concentrations. These are often things like antacids, seltzer, milk of magnesia, and even bicarbonate. Strong acids can be corrosive to metals, things like battery acid. Acids break down food in our digestive system as well. Your stomach has a pH of around 2. Acids generally taste sour if you were to put them in your mouth, but they're found in many drinks that we have as well. Coffee has a pH of near 5, beer usually around 4, and sodas often around a pH of 3. This is one of the reasons that sodas in particular are not good for your teeth. They dissolve the calcium and the enamel on them. Pure water is neutral at a pH of 7. This means that there is an equal concentration of H+ and OH- ions. Bases are fluids that have a greater proportion of OH-. Strong base can be caustic to your skin, causing damage. They often taste bitter or soapy. Baking soda, ammonia, and bleach are 3 examples of bases. Your blood is also slightly basic, usually around 7.4. Because living organisms are so sensitive to pH changes, we have buffers inside of us to help maintain a set pH. A buffer does not neutralize a solution. That would actually be a bad thing. Remember, your blood has a pH of 7.4, so we have buffers in our blood to help maintain that pH level. We do not want to neutralize it and bring it to 7. That would be damaging to our bodies. So, buffers are important because they are molecules that can quickly absorb excess H+ ions to keep the solution from becoming too acidic. They are also able to release H+ ions to counteract any increase in OH- concentrations. The most common buffer found in your body is actually bicarbonate. In summary, this video has covered the importance of water, the 4 major properties of water, and what pH and buffers are.